Good evening. I hope that you guys are all enjoying this thermochemistry stuff. It's some of my favorite things to calculate and work through. So this is just a really quick little example on homework 3. It's just an extension of combining the grams and the monomoles to figure out how much heat is given off. So the first thing that you need to do is, again, we just have to write and balance an equation and make sure that it's done correctly. So the first thing we have is we have nitrogen monoxide. We'll try green this time. So nitrogen monoxide burns to form nitrogen dioxide. So you should be thinking that this is a combustion reaction. So I'm going to write nitrogen monoxide, which is a gas, and it's going to burn. So I know I need to add oxygen gas to this, and I'm going to form nitrogen dioxide. And that is also going to be a gaseous substance, and I need to balance this equation, so I'm going to put a 2 here. And the reason I'm doing that is so that I can make these oxygen even. So I have 2 oxygen here, plus the 2 oxygen over here is 4, and if I put a 2 here, that's going to give me 4, and then the nitrogen balance out. All right, so I go ahead and I take a look on my gold sheet, and I can see that this is going to be an endothermic reaction because the positive 90.4. I know that this is diatomic in its natural state, so that is going to be 0. And this is another endothermic reaction, which is 33.9. All right, so now I'm going to go ahead and I'm going to find my change in heat of this whole reaction, which again is product minus reactant. And remember, you have to multiply by the number of moles that are given. So I have 2 moles of my product, and it releases, or it takes in 33.9 kilojoules of energy. Subtracting from my reactant side, and I have 2 moles of my nitrogen monoxide that takes in 90.4 kilojoules of energy plus 0. And if I calculate that out, I am going to get an exothermic release of 113.0 kilojoules of energy. Okay, so now if we take a look at this, first of all, before we move on to the second part, what I need you to understand is that I have this many kilojoules when I have 2 moles of nitrogen monoxide, when I have 1 mole of oxygen, and I have 2 moles of nitrogen dioxide. Well, in the second part of this question, you're going to see that I don't have a full 1 and 2 moles of my substance, and so I want to find the energy change if it's going to be less than that. So there's a typo here, you guys. I'm not sure if your notes have changed, but this should say 7.53 grams, not liters. Okay, so what would be the energy change if I only have 7.53 grams of, of nitrogen dioxide that was formed? Well, I have 7.53. I don't know how much that is of a mole, but I am going to change that into moles. So I am a pro at that now, so I'm going to take 7.53 grams of nitrogen dioxide, and I know that 1 mole, and I add up the molar mass of that, 1 nitrogen and 2 oxygen, and I get 46.0 grams, and if I calculate that out, I get 0.164 moles. And this is moles of nitrogen dioxide. All right, so now if I take a look at my equation, so this is where I need to use my balanced equation, and I look up here at nitrogen dioxide, and I can see that I have 2 moles of it. And when I have 2 moles of it, I am releasing 113.0 kilojoules of energy. So I just need to go ahead and continue my stoichiometry on that, and by my equation, I have 2 moles of nitrogen dioxide, and I am releasing 113.0 kilojoules of energy. So when I look at that, I can see that my moles cancel out, and I am left with the amount of energy that is going to be released when I have 7.53 grams. And so this equates to releasing 9.23 kilojoules of energy. So that's it. That's homework 3. I do have one more example right underneath here. Let me grab it for you. So if you take a look at homework number 3, you can see that up at the top, we have the product minus reactant again. And it says, since the magnitude and the size of the change of heat of reaction is dependent upon the quantity of reactants and products, do not forget to include the coefficients in your calculations. which hopefully up until now you have been doing a really good job of that. Okay, so I'm taking sulfur dioxide gas, reacts with oxygen gas to form sulfur trioxide gas. So the first thing I need to do is, again, I am going to write and balance an equation. And so I am just quickly going to write this for you. Excuse me one second, my family just got home. I'll pause. All right, my family's done laughing at me now. I'm going to finish. So I have sulfur dioxide reacts with oxygen gas. So if I go ahead and write this balanced equation, there is school tomorrow. So 2 moles of SO2 in the gaseous phase plus oxygen in the gaseous phase is going to yield 2 moles of sulfur trioxide gas. So again, take a look at your heat of formation sheet, and you guys should be able to find all of these values, and you're going to see that this is going to release 296.1 kilojoules of energy. And remember, oxygen is in a natural state, so there's no heat of formation there. And then I am also releasing 395.2 kilojoules of energy here. So remember, it's the heat of formation is products minus reactants. So I have to multiply by the magnitude, meaning the number of moles I have of each substance. So I have 2 moles of SO3, so 2 times its heat of formation. And that is all I have on my product side. So I'm going to subtract my reactant side, which again, I have 2 moles of that times its heat of formation, which is releasing energy, and calculate that all out, and I get releasing 198.2 kilojoules of energy. Now recall that this number here is for 2 moles of SO2, 1 mole of oxygen, and 2 moles of SO3. Now if I read the second part of my equation, you can see that I do not have that full amount, so we really want to see how much energy is being released in this situation. So I have 11.3 grams of sulfur dioxide reacts. What would be the change in energy? So again, I'm just going to take my 11.3 grams of sulfur dioxide, and I am going to convert that into moles. So I know that 1 mole is equal to 1 sulfur and 2 oxygen, and when I add that up, I get 64.1 gram. And calculate that out to 3 significant figures. I get 0.176 moles. And then I'm going to convert this. So here's where I'm going to use my balanced equation. So I'm talking about sulfur dioxide. So I go and find sulfur dioxide in my equation up here. And it looks like I have 2 moles of it, and I am releasing this amount of energy. So go ahead and put this. I need to cancel out moles, so I'm going to put the moles on the bottom. So I have 2 moles here. And when I have 2 moles of it, I'm releasing 198.2 kilojoules of energy. And again, the moles cancel out. I'm left with kilojoules, and I need 3 significant figures here. So I'm releasing 17.4 kilojoules of energy. And it should make sense to you that that number should go down, because here I had 2 moles of it, and here I only had 0.176. All right, good luck on figuring out the rest of these problems. Have a wonderful night, and I will see you soon in class.